Welcome to the channel where all you gotta do is a little reverse engineering. So this is the subframe, rear subframe off of the M6 that I'm, utilizing. So I'm not really too critical about where these upper control arm mounts are because I gotta change the camber curve and caster curve and stuff. So I'm not too worried about that, but I'm using the lower control arms, so I need to know approximately where these are. And it's definitely a binding kind of setup. Obviously, it's going to bind when this guy and this guy aren't parallel. Concentric actually. So I'll probably get rid of this. I mean, I'm going to use lower control arm. It's super light, nice and stout, really good design. But I'll probably get rid of these stupid rubber bushings and put some proper heims in there. But I need to know approximately where those are, and then I'll get that information into CAD, and then I'll design all the control arm lengths and move the mounting positions here and there to get the camber curve I want and the tailwind curve I want. But this is the start, right? I could have taken my 3D scanner and just scanned this thing, but it's going to give me a whole bunch of information that I don't need. Like all of this stuff is going to be completely different, right? This subframe is like an inch, a little over an inch and a half, about 1 5/8 wider than what I need on that car because the car is narrower. So while I'm doing that, I have an axle. These axles are the same length. Left and right are the same. So I got this shorter axle, which is off of a 2011 model, M3 left side. And that's like about 2 inches shorter. So that'll allow me to change the track width by the 1.6 that I need. Plus it'll allow me to move the differential where the drive shaft is back to the center, because this one's off center by, I don't know, 0.8 inches or something like that. So I'll be able to move this back into the center of the transmission tunnel. So anyway, this is the start of it. I just using some basic tools, the yo-yo, angulometer, calculator, and then I just put all the information in my pad. And then when I forget stuff, I can just come back out here and measure it again. So I will also be tilting this thing down. Like this thing's all level right now, or close enough to level that it's also level in this plane. So I can measure stuff fairly accurately, and then I'll tilt it down and get the dimensions from, the up-down dimensions, the Z dimensions. So. Okay, so spent the last hour or so removing this axle. Used to look kind of like that one, but I'm going to use that axle, so I'm going to use taking that one off. But this is the left side suspension, so I had to take the axle off. These are the tools I needed: standard puller, breaker bar, baseball bat sawed in half to put on the end of the, think of a cheater bar or breaker bar. Anyway, so this is what we got. This is M3 20 and the next generation, E92, I think. Same thing I stole the 5-speed out of. 6-speed, sorry. So this is the left side, and it's according to Rock Auto, which is a pretty good source for pictures and dimensions. Spline size, thread size, right? If you're trying to match an axle up, that's probably your best bet. That's what I use. Works pretty good. Anyway, this is the only one they had in stock. It's kind of a cheapo version. I don't even remember the brand, but that one. It says quality right there, so I don't know why I should ignore that, but it was like 90 bucks, so I have a feeling it's no good, but just to make sure it fits, I can buy a quality part later down the road. And the intent with this one is that it would be 1.6 inches shorter. And it turns out, I did the math, I laid it out on the table. That's my end here. And then I compressed it. So that's the range for the M3 axle, that's the range for the M6 axle. And those are the numbers. And there. So it's exactly 1 inch and 5/8 shorter in the compressed state. And the new axle doesn't quite have 2 inches of travel. The old axle does. So it's an 1/8 inch short, but that shouldn't be a problem. So this is going to work out as intended. So I have the subframe up here so I can measure all the dimensions of it, but the track is getting shortened by 1.6 inches as well, right? Because you can't buy wheels in every offset, right? They come in 35 millimeters or 44 millimeters or 20 millimeters or 0, right? This back spacing. So the closest one I could get were these plus 44s. 18 by 11 plus 44, that's the offset, that's the rim size, that's the rim width. So, it's nice when a plan comes together. I got this wheel 6-8 months ago, something like that. Well, I got a whole set of them, but it's the first time I bolted the brake rotor and everything to it. Make sure it's the right offset and stuff, and everything looks super nice. I gotta make sure my calipers fit on there next. Show you that guy as well. I did notice one thing really useful. Like while I'm taking this stuff apart, the other thing I'm doing is I'm weighing everything so I can put it in my weight and balance spreadsheet. So basically I weigh every part individually and then I put it in the spreadsheet on where its location is so I can get a center of mass and polar moment of inertia and stuff like that. But basically, you can see that moving. But this wheel bearing was ready to fall off. That had to be making just god-awful noises. It's really bad. So that's not good, but stuff like consumables like wheel bearings I was going to replace anyway, ball joints, stuff like that. So this is just for the mock-up stage, it's fine. But one of the things I was concerned about, because I don't have all this stuff into 3D CAD yet, is this is where my shock is going to directly mount. So that's nice, because it's outside of the wheel by a little bit. Yeah, 3/4 of an inch or something. Well, half an inch maybe. So that's fine. I could just put a adapter that bolts into this, and then or a spacer, and then it bolts the shock absorber directly to that. So the plan on the brakes for this thing is some some Mustang GT. I think they're 6-piston calipers. I got them down in the wine cellar. I'll go grab those, see what I'm going to need for an adapter. Not that I'm going to have to make them anytime soon, but I want to get all the suspension giblets kind of scienced out and put in CAD, so I don't have any surprises later, right? Because if I have to change my caliper mounting setup to miss something that I didn't know was there, then that's going to throw a wrench in the works later. So, and the other thing is, I just kind of want to take a look at it and see what I got, and then if I don't have a solution today, I'll think about it on my drive to work, you know, whatever. Just think about it constantly in the back of your brain, come up with a clever solution. So it's kind of how I work. So I want to have I can't formulate a clever solution if I don't know what the problems are. Okay, so I'll pop this a little bit more apart, and there's definitely some carnage here from the wheel bearing. That's not supposed to be rubbing on that. Pretty sure these bolts, same thing, not supposed to be rubbing. And yeah, that's no bueno. So this is how the emergency brake works, which is really nice on a track car, actually having an emergency brake. And when you have standard disc brakes, that doesn't work because you're wearing out the pad so fast that there's no way to adjust them in time. So this one doesn't even look like it has an automatic adjuster, which I guess makes sense. Why would the emergency brake wear out? You're only using it when you're going to 0 unless there's an emergency. So you don't really need to adjust it. So anyway, this is not too terrible weight-wise. It's 9-ish pounds. So that's not horrible. I mean, McLaren's not going to want it on their Formula 1 car or anything, but this weighs twice as much as that. Now there's the brake I'm going to put on it. So I needed to get this all apart so I can get this shroud off of here. Comes off this direction. And then there's this chingadera, which is essentially the backing plate, like these little disc or drum brake doodads go in there and rotate. So that's where those go. This is the adjuster, and this is the actual cable. Cable hooks up into that little guy and spreads them. So anyway, we'll get this kind of sort of levered back together without all the pieces that I don't need. Put this stuff in a Ziploc baggie for fun times later. This is what we got. Right in here, and right in here, the brakes, this part and this part are touching each other. So that's not awesome. But I think if we do a little bit of machining on this part, put a chamfer there, then this thing will slide that way a little bit, maybe that far, and then this thing, all the holes will be in a straight line. The way it is right now, that won't happen, but like a top view from this guy, there'll be a hole there, and a hole there, and a hole there, and a hole there, and those will all be in line. So, stay. So, and then this thing will come to the same radius. Now, you might see a few teensy-weensy little problems with that, which is this bolt is going in the wrong side, but that's not a problem. I could either thread this or put a counter bore and stuff in the other side of that and put a bolt in that's not going to hit anything. So this is totally doable. I think my plan Makes a lot of sense. I will have to obviously, trim this guy a little bit or throw it in the dumpster. Probably do the first and then the second. Okay, so the next fitment check is, does it fit inside the wheel? And the answer is yes. Yes, it does. Not by a bunch, but it has some clearance. So, just to make the aesthetics of a 67 Fastback look appropriate, I wanted to go with 17-inch wheels. However, there's a couple of challenges with that. One, you can't get any decent sized brakes in, and rotors, yeah. And two, there's not very good rubber in 17-inch, right? You get a lot more options of, super sticky stuff. Also, drag radials are available in the same size. So this is a pretty popular kind of 315, 30, 18. You can go to bigger sizes, which I can totally fit under there, but I'm going to be limited by turning radius in the front if I get too big and I want a square setup, because the way my weight distribution is going to be, that's going to be better. I do have to make a couple of modifications though, and as you can see, there's about 3/8 of an inch between the pad and the rotor on this side. And on this side, the pad will barely fit in there, which is fine. So that's no good. So what I'm going to do is I'm going to take this rotor, or this caliper apart, these 4 bolts out. There'll be 2 pieces then. And then I'll machine 10 millimeters-ish off of this face all the way across. I'll get it all jigged up so it's nice and straight and square and everything. And machine that on my little old Bridgeport over there. And then bolt it back together. And then this pad will be in the same position. See, you can't make it so this pad sticks out because the pistons will be exposed, and then there's these little wear surfaces. Not really wear surfaces, but these little surfaces in here, which is what takes all the load, right? And you put the brakes on it, it tries to push this pad, and it pushes into that. So if this pad is sticking out like that, that's not going to work, right? So anyway, these were like, I think I paid $80 for the pair, which were brand new takeoffs, which is, pretty decent price for a pair of 4-piston calipers. For the differential, I used a little bit more sophisticated measuring device, which is just a height gauge. Same apparatus. I also 3D scanned it, like really crude, like a 3 millimeter accuracy, as well as the upright and the lower control arm, so I can get that all into CAD. Same deal as the front. You can't rotate it in real time, but you can suppress it, rotate it, unsuppress it. So that's what the parts look like, and that's what it looks like in CAD. Thanks for watching. If you like this content and want more, subscribe, like, and share.